Okay, F.IF.6, this is Interpreting Functions, Standard 6, and it looks like we are going to be talking about rate of change, and I'm also going to add into this video a discussion on slope. We're going to be coming up with graphing something called slope-intercept, and it deals with changes in your x and y axis when it comes to plotting points. So let's go and see what we're looking at here. Terms to know. I'd like you to write these down in your journals and define them. We have slope and rate of change. Okay, it says that the slope of a non-vertical line is the ratio of the vertical change rise to the horizontal change run between any 2 points on the line. The slope is represented by the letter m. Okay, so we have a fraction here. We have a numerator and a denominator, and according to the definition above, when they talk about the rise, I'm just going to underline that right there. When they talk about the rise, think of your coordinate plane. Think of the axis that deals with upwards and downwards. So that would be called the y-axis. So if we have a change, meaning subtraction here, the difference between 2 points, we have a change going on here, and that is going to be the vertical change. And then in the denominator, we have something called the run, and that is going to deal with the horizontal change in the points. So we have our rise over the run. This is the vertical change, and we have the horizontal change. All right, and I kind of have a little separate idea to think about. Think of a balloon. You know, when you have helium in a balloon, what happens to the balloon when it's filled with helium? It goes what direction? It's going to go upwards, and then when you have the balloon run out of helium, it's going to go downward. So when you're talking about the change in the y-axis, think of a balloon going upwards and downwards. And then in the denominator, when you're running, you're going what direction? You're going left and right. That is the change horizontally. So we do the rise first, and then we do the run second. It's kind of opposite when plotting points. Normally, when you plot a point, you start from the origin and you go horizontally and then vertically. But when you're dealing with finding slopes of lines, you're going to do that opposite. All right, here we have a graph of a line. It's in purple, and I have 2 obvious points on the line. Now, normally you don't have to have those obvious points. You would have to locate them where your grid lines meet. I notice I have another section here on the line where the grid lines meet. I don't have any point here, so it would be tough. You're dealing with fractions, maybe some mixed numbers here, but you're going to try to see where your line meets the grid lines, almost like a bullseye here. Oh, we have another one here. Okay, so a couple different ways you can do this. You might just be able to eye it using the idea of rise the balloon and run, just kind of running on a plane, a flat plane. And, I'm going to do it both ways for you. So if we deal with the rise first, and I go from, let's just call this point A and point B, and I rise, so I have my balloon, that's going to be the change in this y-axis right here. So if I were to go rise, I'd go up each unit. So we have 1, 2, 3, 4, 5. The rise was up 6, so we have positive 6 over, and then we do our run from that point that we left off at. Our run would be going what direction? We'd be going 1, 2, 3 units to the left, and left means negative. We moved backwards 3. And if I were to simplify that, positive 6 divided by negative 3 is equal to a negative 2 slope. If you wanted to go from point B down to point A, you can have the same idea. Think of that balloon first. So the balloon runs out of helium. To get down to point A, it would just drop straight down. 1, 2, 3, 4, 5, 6. So that would be a drop of 6 or negative 6. And then from that point, we would run to the right 1, 2, 3 points. And to the right means positive. So again, we have another situation where we simplify this as a negative 2 slope. Now the third way, I'd like to use that equation from the last screen. And it says take one of your y values and subtract your other y value. So y sub 2, we call that a subscript. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right, so then we need some ordered pairs. And we call point B, they actually gave it to us, and that is the ordered pair. Start from the origin, 1, 2, 3. So that's 3, and then we have 1, 2, 3, 4, 5. Okay, so point B is 3, 5, and point A is 1, 2, 3, 4, 5, 6, negative 1. Now, according to our formula, our equation, a slope equation that they gave us, we have to allocate or name our points as subs or subscripts. So it doesn't matter what ordered pair you pick first, as long as you stay consistent in your formula or equation. I'm going to just say, okay, so point B, I have a point 3, 5. I'm going to just call this x sub 1 and y sub 1. It's the first ordered pair that I'm looking at. And then I have x sub 2 and y sub 2 because it's the second ordered pair that I'm looking at. Now if I were to plug that into my equation, it's going to look like this. So m is equal to the fraction. The top is the change in the y-axis, that's our rise. So I'm going to take my y sub 2, which was negative 1, and subtract my y sub 1, which was 5. And I'm going to put that over x sub 2, which was 6, and subtract my x sub 1, which was 3. Let's see what we come out with. Our rise is negative 1 minus 5 is negative 6. And our run is 6 minus 3, which is positive 3. And that simplifies again to negative 2. So if you are given a picture, just that plain purple line, and you notice these two major points, almost like the bullseye or the points at which your line hits the grid lines, you can eye it and do your rise over run quickly. Or if you're just given 2 points, like without a coordinate plane, then you would have to run it through your slope formula. You still get the same answer. These are all negative 2 slopes. All right, and here's what I was talking about. So let's say we don't have any graph paper, and they just give us 2 ordered pairs, and they want you to find how much slope this line has, if any. Maybe it doesn't even have a slope. Following the formula, I'd like you to pause the video and you choose which ordered pairs you would like to be your sub 1s and your sub 2s. It doesn't matter who is who, just as long as you stay consistent when you plug them into your formula. Okay, we're back. Since negative 10, negative 2 is the first in line, I've just chosen them to be my sub 1s. And my second ordered pair is my sub 2s. All right, what do we have here? We're subtracting, and my y sub 2 is right here, 8. My y sub 1 is over here at negative 2. x sub 2 is negative 8 right here, and my x sub 1 is negative 10. All right, so we have 10 in the top, and we have, let's see, add the opposite. This should be positive 2 in the bottom. And if I were to simplify this, the slope of my line is 5. 5 over 1, or simplified to 5. All right. Now I have two special cases. I have the red line and I have the purple line. One is running parallel to the y-axis, and the other line is running parallel to the x-axis. So let's just grab two quick points that are on our lines. Let's do the purple one first. And I noticed that, well, let's stay positive. It's probably easier that way. So I'm going to take this ordered pair. It's on my line, and I'm going to take another one maybe over here, and I'm going to plot them. So we'll call this point A and point B. My point A is 1, negative 2. And my point B is, what? 2, 3, 4, negative 2. Quickly plug that into our slope formula, and I'll make these my 1s and my 2s. Subtracting them, finding the change in the slopes. Finding the change in the ordered pairs. So we have y sub 2 is negative 2 right here, subtracted by the other y sub 1, which is also a negative 2. And then we have 4 minus 1. So what do we end up with here? Add the opposite. Negative 2 plus 2 is 0, and the bottom is 3. So we have a situation where no matter what point you pick on this line, all of those, you're going to end up with a numerator of 0. So in this particular case, the purple line is going to be m is equal to a 0 or no slope. So you could call it 0 slope or no slope. All right, get that written down. And then I'm going to erase this and show you what happens with the vertical red line. All right, so we could choose two random points on the red line now. Let's just get this purple one out of here. We don't really need that anymore. Okay, the red one, if I choose two random points, now let's take this one and this one. What do you think is going to happen here? All right, so point A and point B, we have the ordered pairs of 1, 2, 3, 1, 2, 3, 4. So we have 3, 4, and we have 3, 1. I think you can see it already. All right, so let's do our fraction. M is equal to the change in the y. So the change in the change we have, all right, we'll call these our 1s and our 2s. So we have 1 minus 4. 1 minus 4 over 3 minus 3. And that's going to give us negative 3 over 0. Now, you are not supposed to have a 0 in the denominator of fractions. Do you remember what we call that when we have a 0 in the bottom or the denominator? We call this an undefined slope. Undefined. So m is undefined. It's not 0, it's not no slope. There's a difference. When 0 is in the numerator, we call it 0 or no slope. When it's in the denominator, this is always a no-no in math. We don't want that. That's called undefined slope. So that is your vertical line that has no slope to it. There's no tilt to it, and your denominator is 0. All right, now we're going to talk about rate of change. A rate of change compares a change in one quantity to a change in another. So basically what we're going to be doing now is we're going to be looking at tables and graphs and kind of reading the numbers and see what kind of relationship they have to each other. And here we have, what is this? The cost of using a computer at an internet cafe for a certain amount of time. So what is the range, what is the rate of change in costs with respect to the time? All right, so here's another case where we can use our slope formula, and we take just any 2 points on our line, and we see that we have, every 2 hours or so, we add 2 hours to get 4, and we add another 2 hours to get 6, and it looks like we have a pretty consistent pattern here. So I'm just going to take 2 random points. Obviously, this is your X, or your input, and the cost is your output, or your range. And that means I have my first ordered pair, I have 2, 7, and I could just take 4, 14. I could use 6, 21 if I want, but I'll take these 2 random points. I don't know what I'm doing with those. I just didn't want X's in there. So let's go. We have 2, 7. And we have another one of 4, 14. And let's see, what do we want here? I want some easy subtraction. So I'll make these my sub 2's. Recall, you can choose either one to be your sub 1's and sub 2's. It won't matter as long as you stay consistent in the formula. So if I have the change in both my X values and Y values, we have Y sub 2, which is 14, and we have Y sub 1 is 7 over 4 minus 2. So we have 7 over 2. So it looks like if we were to reduce that, 7 divided by 2 is 3.5. So if we did it in terms of money, we could say that we have $3.50 per hour. So the rate of change is per 1 hour, we have a change of $3.50. All right, last one. In this graph, we don't have any given numbers for your X values and your Y values. They want you to kind of use words and try to determine what's happening here. So we have time in minutes and distance in miles traveled. So I guess we can equate it, since you're students at school, maybe how you are getting to school for the day. Maybe you take a bus, maybe you walk, maybe you get a car ride. But I'm going to read this as the starting point in this far left corner at the origin. You are standing still. And as we move across the grid, time is elapsing. And it's not a very steep line. You know, if we went by a few minutes, maybe 1 minute or 2 minutes, maybe you go increments of 5 minutes, so 5, 10, 15, 20 minutes. It's not a very steep line when it comes to the distance in miles traveled. So I'm assuming that this student is walking from point A to point B. Now what's happening from point B to point C? There isn't any change. We have 0 slope going from point B to point C. Time is elapsing, but distance traveled is not changing. So I'm going to assume that this student has walked to the bus stop very slowly and now they are waiting for some time to get to C, and now we have a very steep line as you get up to point D. So at this point, I'm going to make a judgment that the student has gotten onto a bus or into a car, and the distance traveled has gone up dramatically, so they are at a higher rate of speed. So again, from A to B, they are walking slowly to the bus stop. For some time that has elapsed, they are just standing there waiting. No distance has been traveled, and then a very quick change in time and speed and distance traveled. We have them probably getting on the bus and heading off to school. So that's just working a graph, reading points and making assumptions, estimating what might be happening. Okay, in your journal, I'd like you to define the two terms that I gave you on page 2 of the flip chart and write a few sentences on what you think you learned from the video. If there's anything confusing, as always, please bring those to class. That's what really drives us when we get back together so that we can work on these together as a class.